Hi guys, another 9.3 video today for us, and we are going to talk about what types of objects can I find the surface area of. And we've kind of hit all the important objects that we need to learn about this year in our particular line of study of what we're doing. And so this is more of a review video. I want to look at what are the different things we have done. And so in our notes here, I'm going to divide it into a couple of sections. We're going to focus on what are some of our main ideas. So first off, when we started learning about surface area, we began with prisms. So I'm going to write that over here, prisms. Prisms are interesting. Prisms are objects that have a base that matches a lid. It has a top and a bottom that match. And I have a bunch of examples over here of some blocks I can show you. So this is a prism. It's got a square top and a square bottom. That's what makes it a prism. Even if I turned it this way, it's got a rectangular top, and then if I flipped it, a rectangular bottom. So it's got matching dimensions, basically, on opposite sides. That's a really good example. Here's a perfect cube, but it's also a prism because if I flip it, everything matches. It has opposite sides, left, right, top, bottom. And there's different types. Here's a nice triangular prism. It's got a triangular top that matches its triangular bottom. And then if you look at the sides, we've got rectangular sides. So all of these objects are types of prisms. And so for my example here, I'm going to do a picture of probably a rectangular one. I think it might be my strength at drawing. So I'm going to draw a picture of like a square. And then maybe a matching square back here. And then I'll just connect my corners. And there's my rectangular prism. I think the key thing to note about prisms is it's got that matching top and bottom, the base and the lid. So you can think of it as like top and bottom, or you can think of it as like a base and a lid. However you want to think about it, but it matches. So we've learned how to find the surface area of these things. We break it into parts. We do top, bottom, left, right, front, back, and we look at all those sides. The other thing we've been learning about is called pyramids. We've been learning about the surface area of pyramids, and pyramids are a little bit different. Let's see, I have one pyramid example. I don't have a ton of these, but here is my pyramid. What makes the pyramid different, it might be hard to see on my screen here, is that the pyramid does have a base. Look, this one has a square base, but it doesn't have a matching lid. If I flip it, it meets at this sharp, tiny point at the top of the block. So there's no top, bottom, left, right matching sides. Instead, it's one singular base. It's either the shape of a square or it could be other shapes like rectangles or triangles. And then everything meets at a pointed top. So a little bit trickier. So with pyramids, you got to remember that it has only one base and meets at a point. And meets at, ooh, what am I writing? Meets at a point. Sorry, these notes are not as nice as I was hoping to make them. They're kind of messy. And if you can draw a pyramid. You guys know, some of you guys know that drawing pyramids is not my strength. So I have just a little picture of a pyramid I'm going to put right there. If you feel comfortable with, it's kind of nice to draw one in your notes. If you feel comfortable with drawing one, go ahead and pause the video and draw a pyramid. Give it your best shot. And then I'm going to kind of move forward here. I've done prisms and pyramids, and the newest thing we've added to our abilities is cylinders. And cylinders are interesting because cylinders involve circles. And the second we talk about circles, we're talking about the number pi. So I've got a couple cylinder blocks here as examples. They've got circular tops and bottoms. So like a prism, they have a matching base and lid. That's kind of nice. But these things actually roll. That's the difference between them. So cylinders, let's see here. I'm going to draw a picture of a cylinder. Have these circular tops that match these circular bottoms. So it does have like the whole base and lid thing, or top and bottom. I mean, that's nice. But top and bottom, base and lid, whatever you want to say here, what I do know is that whenever we're doing a cylinder problem, we got to use pi. We got to use 3.14 because we've got that round object. So those are kind of the only like three things we've worked on when it comes to surface area. But honestly, those are the only three that we really need to know in our curriculum that we're working with. So let's just do a little bit of practice here for a few minutes. I'm going to move this out of the way, and let's try an example. So we're going to do example 1. And for our first example, why don't we start by looking at what do you want to do? How about a prism? So for our prism, what I'm going to do is I'm going to draw a triangular face, something like this. And then behind it, I'm going to have basically a matching triangle, I hope. And I'm going to connect all of my corners. Kind of looks like a tent or something. Something like that. So this is definitely a prism because it has a matching triangular face on the front and back. In fact, I just did this thing. You can see it here. It's got a triangle on top. It's got a triangle on bottom. Or in this case, it kind of looks like the front and the back. But to find our surface area, we're just going to break it into those parts. So let's get some numbers. If we don't have numbers, this isn't even solvable. So let's say that someone came in and told us the length of this object from here to here measures 10 centimeters. 10 centimeters. We're also told that the front part of this object, from here to here, measures a distance of 4 centimeters. And if I drew a dotted line and made a 90-degree angle, that line right there measures a distance of 4.5 centimeters. And that's all I know about my prism, is those numbers. All right, so let's find the surface area. Now I'm going to grab some colored pencils for this one, because this is a perfect example of where we could color the different sides, or faces, I guess we should say. So why don't we start with the triangular face, this thing. How many triangles do we have in this problem? There's 2, right? There's the front and the back. So what I'm going to do is I'm going to draw a smaller version of that triangle over here. And I'm going to label that as my front and my back. So front / back. And what I know is the measurements of this thing is it's got a dotted line with a 90-degree angle. It's right here. Measures 4.5 centimeters. So this thing is 4.5. I also know down on the bottom that it's 4 centimeters long. So 4. And what I'm going to do is I'm going to color this one to match my one in my picture there. So it's organized. Now we're finding surface area. So I got to find the area of this triangle. I'm going to do area equals base times height divided by 2. I'm going to write my formula, and then I'm going to do area equals base, which is 4, times height, which is 4.5, and then we'll divide by, 4.5. It's a bad looking 5, I'm sorry you guys, divided by 2. Maybe I can write in a darker marker here. 4.5. It's a really bad 5, I'm sorry guys. But you know what we're doing. We're going to do 4 times 4.5, and then we're going to divide by 2. So 4 times 4.5 is 18. Oh, nice. So we got to do 18 divided by 2. I don't need a calculator. So 18 divided by 2, area equals 18 divided by 2, which is 9. So equals 9. So now we know that the area of this triangle is 9 centimeters squared, but there's 2 of them. There's a front and a back. What's left in this object that I need to deal with? Well, what's left is this rectangular side that looks kind of like this. Do you see it? Can you see the rectangular side? So I'm going to draw this rectangular side right here and probably color it to match. So I'll color this in something like this. And there we go. Sweet. Okay, so what are the dimensions of this thing? Well, looking at my picture, it looks like it's definitely 10 centimeters long. So 10. And then, let's see. Ooh, there's no, well, I kind of wish I had had some more numbers written on here. I'm kind of making an assumption that this triangle goes 4 by 4 by 4, but didn't actually say. But I'm thinking that's what it is it's 4 by 4. So I think it's a 4 by 10 rectangle. And the area of rectangle that's 4 by 10 is 40. So our area of this thing is 4 times 10 So area equals 40. Now, how many of these rectangles do we have? How many of these faces? Well, here's my triangular prism, my block. If I take it and spin it, watch. 1, 2, 3. There's only 3 of these rectangles. You can picture them because they're on the outside edge here. 1, 2, 3. So what I'm going to do is I'm going to label this the faces. And I'm going to write times 3 over here so I don't forget that. So now I'm ready for my total surface area. And I'm going to write total surface area, total SA, equals, let's see, what do we need to do? Well, we need to do 2 of the triangles, which were an area of 9. So 2 times 9, plus how many of these rectangles? There were 3. Remember we wrote times 3? And these are 40. So we're going to do 3 times 40. And then I'm ready to put this math together. So let's see here. 2 times 9 is 18. 3 times 4 is 12. So with a 0 is 120. So I'm going to add up 18 plus 120. Well, 120 plus 10 more is 130, plus 8 is 138. So my total surface area is 138, and I think we were measuring in centimeters, so I get to write centimeters squared. And we've got our answer. That was nice. We didn't really need a calculator too much on that one. So final answer, 138 centimeters squared. My strategy for all of this was color the faces, color the sides, look at them carefully, draw them out, and individually find each of the areas. Does that kind of make sense to you guys? All right, guys, we're going to do our last example for this video. And I cheated a little bit. I went and used my computer and I printed out a picture of a pyramid with a square base. I challenge you to try to draw it in your notes. Some of you guys are really good at drawing these. It's good to practice, but I thought if I wanted you guys to be able to see it and understand it, I better print it out because my drawings, I still need some practice. But what we're going to do is we're going to find the surface area of this thing. And I like to start with the base first. I like to kind of focus my energy on what's the shape of the base because they're not always going to be squares. This case is a square. So I'm going to draw the base over here. I'm going to label it base. And I'm going to write the dimensions, which in this one, it looks like it's a 7 by 7. So what I get to do is I get to label it 7 by 7. And a 7 by 7 has an area of 49. 7 times 7 is 49. So our base has an area of 49. But when you're looking at your pyramid, how many bases are there? Well, that's what's unique about a pyramid is there's only the one base. Everything meets up at a point. So there's only one of these. I don't times this by anything. So next to the word base, I'm going to write times 1. But what's the rest of this picture that I need to figure out? Well, the rest of this picture is the triangular faces. So you can see one of them right here. I can color it in green, how about? There's one of them. But how many triangular faces are on this thing? Well, if it's in the shape of a square, then on the outside edge, we've got 1, 2, 3, 4 different triangles. Look, they're right here. 1, 2, 3, 4. So we have to find the area of one of them, and then we've got to times that by 4. So I'm going to draw my triangular face here. I'm going to label it face, and I'm going to write times 4 because I remember there are 4 of these. And if you look really closely at my picture, now it's probably small on your screen, I apologize, but there is a light dotted line down the middle. It's right here, and there's this little 90-degree box down here, indicating that the height line is this thing. It's 11.5. So right down the middle of this triangle is an 11.5 height. And I want to know what's the length of the base on the bottom. So if you look, it looks like on the bottom it's a 7, so 7. So to find the area of this triangle, I'm going to do area equals base times height divided by 2. And in this case, it'll be 7 times 11.5. Area equals 7 times 11.5 divided by 2. Sweet, okay, 7 times 11.5 divided by 2. Well, let's use a calculator. Let's do 7 times 11.5. 7 times 11.5. And that's going to be 80.5. So we can write that down. Area equals 80.5 And then we got to divide by 2. So I'm going to type in divide by 2, see what I get here. 80 divided by 2 is 40, so it's like 40.25. So my area equals 40.25. All right, and that's my triangular face, but don't forget there are 4 of these. So time for total surface area. Total surface area equals 1 base, which was 49, so 49, plus 4 faces. So 4 times the 40.25. And we're going to add all of that up to get our final answer. So 4 times 40.25, well, I already have the 40.25 in my calculator, so I'm going to do times 4. I'm going to get 161, and then I'm going to add 49 to it, add 49, and I'm going to get my final answer, 210. So the surface area is 210, and if you look at the units, we're talking miles, so this is a big thing, miles squared. 210 miles squared. All right, final answer, there it is. Again, just like the last example, my strategy is draw it out. Color the faces, maybe I'll color this triangle to match it. I think that would be probably smart. But draw the picture and really try to picture the object and understand it. If you can see it in your head and you can kind of understand the shape, then you can slow down and say, I'll just find the area of all the parts on here and put that all together and add that up. That is the strategy. So thanks for watching the review video, you guys. If you're having any trouble with cylinders, go back and maybe rewatch some cylinder videos because you really want to understand surface area well. Thanks, guys. Have a good day.